les gens ont toujours des trolls qui disent que ça c'est dangereux. Mais on sait que dans notre terre, les bombardements et donc c'est comme ça, qui est même plus haut que sur la racine. Et donc tout ce qui est produit a été là depuis 4 milliards d'années. Et la Terre est toujours là. Et la même chose, c'est le Soleil, la Lune, les planètes, les objets dans l'univers. Et donc, si les partitions dans le monde, on observe plus ou moins ça.
What I did today is that I observed these particles inside the atom.
Shouldn't empty space have zero energy? In fact, it doesn't. Quantum physics says quite the opposite. The vacuum is like a frothing sea full of so-called quantum fluctuations. These are pairs of virtual particles and antiparticles that spontaneously appear and then quickly destroy each other before they can be observed. This turmoil should give rise to a huge vacuum than we can observe. For a long time, this puzzle was ignored. But recent measurements have shown that apparently there is a vacuum energy which is now called dark energy. We know about its a whopping 70% of the total energy of the universe. Although that sounds like a lot, it is actually incredibly little compared to our theoretical estimate of how large the vacuum energy should be. These estimates indicate that it should be bigger by 120 orders of magnitude. That's a 1 followed by 120 zeros. How can we possibly explain this huge discrepancy? Hundreds of physicists have tried to come up with solutions. Some theories require extra dimensions of space. Others suggest new kinds of matter or modifications to Einstein's equations. But none of the proposed explanations has been convincing. Are we discouraged by this? Actually, we find it very exciting. Nature has confronted us with a mystery of truly cosmic dimensions. Whoever can solve it will open the door to a much deeper understanding of the connection between the tiniest and the largest scales of the universe. That will certainly be worth a Nobel Prize.
I'm Albert Einstein.
European Organization for Nuclear Research, also called CERN, CERN organization in Switzerland, in Geneva, Switzerland. This organization, international organization consists of a lot of countries. US, France, Switzerland, and a lot of scientists from all over the world, more than 100 countries, work here to discover what happened in universe, and study every proton, neutron, particle in universe, in how we met the universe, and what happened for the world here. So this group of students, they come here to study too. So the internet, while World Wide Web discover here. What we use on the internet discover here. www, that means World Wide Web, different discover here by engineer, England engineer named Tim Berners-Lee in 1989. So he discovered here, and that's why we use internet in the current time. Also discover the touch screen on the phone. When you use the phone, you use your finger to touch on the screen instead you key in ABCD, something like that. And they discover the touch screen, also discover here. That's why we at a time of being we use the phone or computer with touch on the screen. We can do a lot of things fast and easy. That discover in here in Switzerland. So they inside here, inside this building, they display how scientists discover the particle, proton, everything in the world, in the universe. Also here, another lab, another display, or another side of the building. This funded by mainly by U.S. and European country.